All right. We are now on MDN Web Docs Guides, getting started with the web, how the web works. This is the last one of this first section, and then we can get started with HTML structuring the web tomorrow. All right, so how the web works provides a simplified view of what happens when we view a web page in a web browser on our computer or phone. This theory is not essential to writing web code in the short term, but before long we'll really start to benefit from understanding what's happening in the background. Okay, so clients and servers. Computers connected to the internet are called clients and servers. A simplified diagram of how they interact might look like this. So client, that's us, requests something from the server, and then the server sends something in response to us. Okay? So clients are the typical web user's internet connected web devices. What did I just say? Clients are the typical web user's internet connected devices. For example, our computer connected to our Wi-Fi or the phone connected to the mobile network. And web accessing software available on those devices, like web browsers like Firefox and Chrome. So servers are computers that store web pages, sites, or apps. When a client device wants to access a web page, a copy of the web page is downloaded from the server onto the client machine to be displayed in the user's web browser. Okay. So the other parts of the toolbox, the client and server we've described above don't tell the whole story. Oh yeah? There are many other parts involved, and we'll describe them below. For now, let's imagine that the web is a road. On one end of the road is the client, which is like our house, and on the other end of the road is the server, which is a shop we want to buy something from. And so we got a Beatles fan over here. Here we go. In addition to the client and server, we also need to say hello to our internet connection, which allows us to send and receive data on the web. It's basically like the street between our house and the shop. Also, the TCP/IP, which is a transmission control protocol, and internet protocol, which are communication protocols that define how data should travel across the internet. This is like the transport mechanisms that let us place an order, go to the shop, and buy our goods. For example, this is like a car or bike transport mechanisms. You forgot what the word vehicle was, bro? Whatever. Anyway, I wouldn't make fun of them if these guys weren't filthy rich, you know what I'm saying, and still messing up. But whatever. DNS, domain name system. It's like an address book for websites. When we type a web address in our browser, the browser looks at the DNS to find the website's IP address before it can retrieve the website. The browser needs to find out which server the website lives on so it can send HTTP messages to the right place. We'll see that below right here. And this is like looking up the address of the shop so we can access it. All right. So we've got the HTTP right here, Hypertext Transfer Protocol, which is an application protocol that defines a language for clients and servers to speak to each other. This is like the language we use to order our goods. We've also got this these components files, which a website is made up of many different files, like we've seen in the previous videos, which are like different parts of the goods we buy from the shop. These files come in two main types: code files. Websites are built primarily from HTML, CSS, and JavaScript. Clearly, this thing was written before this stuff came out, and then slapped on the end of this thing. Anyway, whatever. That's just my opinion. Though we'll meet other technologies a bit later. Also, we've got assets, which is a collection of names for all the other stuff that make up a website, such as images, music, video, Word documents, and PDFs. So what happens exactly? When we type a web address into our browser, for our analogy, it's like walking to the shop, the browser goes to the DNS server and finds the real address of this server that the website lives on. We find the address of the shop. The browser sends an HTTP request message to the server asking it to send a copy of the website to the client. We go to the shop and order the goods. This message and all other data sent between the client and the server is sent across our internet connection using TCP/IP. Okay. If the server approves the client's request, the server sends the client a 200 OK message, turns out, which means, of course, you can look at that website. Here it is. And then starts sending the website's files to the browser in a series of small chunks called data packets. The shop gives us our goods and we bring them back to our house. And then we've got this browser. The browser assembles the small chunks into a complete web page and displays it to us. The goods arrive at our door. New shiny stuff. Awesome. Okay. So the order in which component files are parsed. When browsers send requests to servers for HTML files, those HTML files often contain link elements referencing external CSS style sheets and script elements referencing external JavaScript scripts. It's important to know the order in which those are parsed by the browser as the browser loads the page. The browser parses the HTML file first, and that leads to the browser recognizing any link element references to external CSS style sheets and any script elements references to scripts. Okay. Let me read that again. The browser parses the HTML file first, and that leads to the browser recognizing any link element references, I said referencing, I think, to external CSS style sheets and any script element references to scripts. Okay, that makes more sense. As the browser parses the HTML, it sends requests back to the server for any CSS files it has found from link elements and any JavaScript files it has found from script elements. And from those, then it parses the CSS and JavaScript. Okay, so first it gets the HTML, then it comes and gets the CSS and the JavaScript. So the browser generates an in-memory DOM tree from the parsed HTML, generates an in-memory CSS structure from the parsed CSS, and compiles and executes the parsed JavaScript. Oh, okay. And the browser builds the DOM tree and applies the styles from the CSSOM tree and executes the JavaScript, a visual representation of the page is painted on the screen, and the user sees the page content and can begin to interact with it, whatever that means. So DNS explained. The real-world web addresses aren't nice, memorable strings that we type into the web address bar to find our favorite websites. They are actually special numbers that look like this, probably the Mozilla site. This is called an IP address, and it represents a unique location on the web. However, it's not very easy to remember, is it? That's why the domain name system was invented. The system uses special servers that match up a web address we type into our browser, like mozilla.org, to the website's real IP address. Okay. So websites can be reached directly via their IP addresses, and we can use a DNS lookup tool to find the IP address of a website. All right. So packets explained. Earlier we used the term packets to describe the format in which the data is sent from the server to the client. So what's meant by that? Basically, when data is sent across the web, it's sent in thousands of small chunks. There are multiple reasons why data is sent in small packages. Small packets, and sometimes they're dropped or corrupted, and it's easier to replace small chunks when this happens. Additionally, the packets can be routed along different paths, making the exchange faster and allowing many different users to download the same website at the same time. If each website was sent as a single big chunk, only one user could download it at a time, which obviously would make the web very inefficient and not much fun to use. All right, so there we go. So we can see also all this other stuff, maybe one day, but not today. And this one just takes us right back to getting started with the web, and we're not going there. So next up, we're on this structuring the web with HTML, and we'll see you next time.